Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at solving triangle problems. Now, solving triangle problems is kind of in the title. It's where we've got triangles and we might need to work out a side, we might need to work out an angle, but it's not as simple as just using the sine rule or just using a version of the cosine rule, okay? You kind of might have to do the sine rule, then the cosine rule, then maybe use some triangle facts from GCSE that you've done before so that you can get the problem solved. Now, what I'm going to do is I'm going to take you through quickly the criteria for using the sine rule and the cosine rule, when to use it and what it finds. Hopefully that makes sense. I'll show you the first example. So, in the first column we've got to find a whatever. In the second column we've got given, so to find this, given that you've got this information, we want to, in the third column, use the whatever rule. So let's have a look. The first one says, if we want to find an unknown angle, and we have two sides of the triangle and one opposite angle. Okay, so if I do a little sketch, if this is my triangle here, and I want to know this angle here, I'll write it in black, and we have two sides and an opposite angle, so we need this side here, let's say that's 1 and this side is 2, okay? These are my two sides, there's one and there's one, and we have an opposite angle, so we need maybe this angle as well, okay, that's the red one. Then we've got two sides, and one of the sides has an opposite angle. So we want to use the sine rule here, because we've got a side and an opposite angle, and another side, there's my two sides, and that's the opposite angle, to work out this side. So if we want an unknown angle and we've got two sides and then one opposite angle, we want to use the sine rule. Okay, let's have a look at the second in the table. If we want to find an unknown side and we have two angles and one opposite side, again we want to use the sine rule. So let me draw a little triangle up here. Okay, here is my triangle, and we have two angles, so let's say we know that angle and we know that one, and we have one opposite side, so an opposite side to any of those angles, let's put that as 1. And we want to work out an unknown side, so we want to work out this side here, then we're going to use the sine rule, because we have two sides. Oh, sorry, we have one side and a side that we need to know. We have two angles, and one of those angles is opposite the side we know, so we're going to use the sine rule. I'm going through this quite quickly because I covered this in the video on the sine rule and then in a minute on the cosine rule as well. It's just quite useful to go through the information before we do some triangle problems. Okay, so next, if we want to find an unknown angle and we have all three sides of the triangle, then we want to use the cosine rule. I think that's quite straightforward. Picture a triangle, you know all three of the sides, they're all given, and you want to work out an unknown angle, use the cosine rule. If we want to work out an unknown side and we are given two sides and the angle between them, so let's do a little sketch here, okay? We've got two sides, let's say that's side 1 and that is side 2, and we know the angle between them there, and we want to work out an unknown side, so clearly that's going to be that one because we know the other two. We want to use the cosine rule there, and we've covered that in the cosine rule lesson. And then I think this is the last one. It is here, we're looking at area. To use the area formula, which is this here, a half times AB. AB are two sides, and sine C. C is the angle between them. Then this is what we need to use that. We need two sides and we need an angle between them. So if we wanted to work out the area of this triangle here, we would need two sides, so let's say that's side 1 and that's side 2, and we'd need to know the angle between them, and we can then plug it into this formula here, with this being side A and this being side B, or the other way around, it doesn't matter because it's multiplication here, and then sine of this angle here will give you the area. So hopefully you actually know all of that, and that was just a little recap, but it might be quite good maybe to take a screenshot of that table or write it out so that you've got the rules, what you need to be given to use those rules and what it finds. Okay, let's have a look at the first example. Now, I have actually already done the solution to this because it is quite complicated. But what I've done is I've split it into steps. So, still pause and have a go. If you're stuck, then maybe wait until I've revealed the first step and see what you can do. All of these boxes are different steps in the solution, but I would have a go. Before we do that, let's read through the question and note a very key sentence. It says, ABCD is a square. So actually, that is quite key. ABCD is a square. So this shape here, by looking at it, we can kind of see it's a square, okay? But we're told it, so we can definitely use information about squares. It then says angle CED is obtuse. Now, angle CED, you take the angle at the point which is in the middle, so at the point E. And it's basically this angle here. It puts a little hat on it sometimes on the middle letter to show that's where the angle actually is. And it's CED, so it's this angle in the middle here. And that angle, and I'm going to highlight this in red, is obtuse. Obtuse means greater than 90 and less than 180 degrees. So when you get to, in the solution, working out that angle, you want to make sure that your angle makes sense. Just looking at that angle, it doesn't really look like it's past 90 because the drawing can be a little bit, what's the word? It can put you off a little bit. But we are told in the question that angle CED is obtuse. So you want to make sure your angle that you calculate is obtuse. What do we need to do that? We'll get to that in the solution. The question is asking us to find the area of the shaded region. This is the shaded region here. And we've got a square basically made up of 4 triangles. So just think about what you can do. You know this angle is 40. So kind of ignore that you're trying to work out the area of the shaded region for the minute. And just think, what can I do with the information on the diagram? We've got DE or ED, whichever way you want to say it, is 8 centimetres. This one side of the square is 10 centimetres. So what does that tell us about these other sides? That's why I noted it was a square. And then here we've got an angle of 40 degrees. So we can work out that one because we know what that full angle is there because it's a square. So pause and have a go, see what you can do, see how far you can get, and then press play and I'll work through the answer. I'm just going to reveal the solution step by step so that we can go through each step and explain why we're doing it. So the first step is the yellow box here, and I'm going to work out the area of the square. Even though you don't really know why you're working out the area of the square, it's always useful if it's a little calculation to just do it anyway, in case you need to do it. Now, it's quite easy to work out the area of the square, because we have one side as 10 centimetres, so every other side of the square must be 10 centimetres. So just to work out the area of the square, that's just 10 times 10. Okay, so we now have, if you've done lots of questions like this, we have the area of the full shape. If we can work out the area of the full shape, then we might, depending on which kind of path we take to do this question, be able to work out maybe the area of these 3 triangles and then take it away from this area. I actually think now, thinking about the solution, we don't do that, but you possibly could do that if you did the solution like that. But it's always useful, even if you don't know why you're doing something, to do it if you spot it. Okay, I've spotted that I can work out the area of the square, so let's do it and see if we need it in the solution. Okay, the second part of the solution is this here, and I'm working out the angle ECD, and that is the angle at C, from E and D where they join, so ECD, it's this angle here. So I'm going to write that on in red, and I'm working that out just by doing 90 minus 40. We know it's a square, so this must be a right angle. We've already got an angle made up of 40 degrees here, so what's the rest of it? It must be 50 degrees, and I'll write that on there. Okay, now this next bit is quite a big section, and what I'm going to do is I'm just going to drag this down, and hopefully you recognise that here I am using the sine rule, because we've got a ratio of sine divided by something is equal to sine divided by something. Two ratios of sine equal to each other. And I'm actually working out angle CED. CED. And the reason I'm going to do that is because then what I have is, well, we know that DC, this side here, is 10 centimetres because it's a square. We know this one is 10, so this side must be 10. And then if you think about it, I am working out this angle here by using the sine rule. And we can use the sine rule because we have two sides and one opposite angle. If you think back to the table we just went through, I'm trying to find an unknown angle, so I need two sides and an opposite angle. That's what I've got. I've got 8 centimetres and an opposite angle of 50, and then I've got this side here and I'm trying to work out that angle. So I can use the sine rule. The reason I'm doing that is so that I can find this angle. So just basically work through the calculation. I'm going to multiply both sides by 10, and I think I'm just going to delete that now. Here, multiply both sides by 10 gives me this part here. And then I'm just going to inverse sine like this, just to give me the angle that I want, which is 73.2468 degrees. Of course that carries on, I think, but that is the angle. Now I'm going to write that on the diagram. So 73 point, what was it, 225 will do, to 2 decimal places just for the minute. Now that is the angle that I get when I do inverse sine. It gives me an angle and I can just work it out and take it. However, I highlighted a very key question, or a key word, sorry, in the question. Obtuse. We've just worked out angle CED, and it told us that angle CED is obtuse. Again, don't go off the diagram because the diagram can be quite deceiving. We're going off the wording in the question, and that is a fact. So, what do we need to do? Well, 73 degrees is not obtuse because it's not past 90 degrees. So what we need to do is we actually need to take away this from 180. And the reason we do that is because of the repetition of sine. You've probably seen it at GCSE before, the sine wave. I think we get on to that in another lesson soon. But the sine wave repeats every 180 degrees. So I've done inverse sine to give me this answer. But kind of hidden in your calculator is another answer, and to find that when you're using sine, you just take it away from 180. So 180 minus this answer here from what I got when I did inverse sine will give me another angle, and that is what this angle is here, not 73 degrees. So that's 106.753 degrees ... Okay, so let me write that on, and I'll just write 106 degrees just for ease, okay? That's what we've got there. Then, the next step is this. I'm going to work out, and I'll do it in a different colour, I'm going to work out this angle here, because what I'm trying to do now is, in the next step, work out the height of the triangle. The reason I'm going to try and work out the height of the triangle is because it gives me a right angle, and then this triangle here is a right angle, and that will then allow me, when I've got this height, which I'll do in green, this height here, that will allow me to work out, and I'll do it in orange, the height of the shaded triangle, because I have the full length of 10 centimetres there. So, what we did is, well, we know it's a triangle, so we know the angle sum of a triangle is 180 degrees. So we can just take away, really, what we've already got. We've got, from this triangle here, we've got 106 and 50, so take that away from 180 will give me 23.25. So this angle here is 23.25 degrees. Hopefully this is making sense so far. It actually isn't very complicated maths that you're doing, it's just knowing the order to do it, and that's why I've actually written the solution out already. So now what we have is we have a right-angled triangle with two sides. This one is 8 centimetres, and oh sorry, just one side actually. The full side is 10, not that one. We've just got one side of 8 centimetres and an angle of 23.25 degrees. We don't know this angle, don't be deceived. It's the full angle that's 106, not that one there. And we know this is a right angle, so what we can do is we can actually use trigonometry, okay? And we can use trigonometry to work out the height of this side here, or the height of the little right angled triangle. To do that, we're going to do our basic trig. If you're unsure of that, go back to your GCSE notes. We've got sine of this angle here is equal to the height divided by 8. You can use SOHCAHTOA to get this ratio. And then you could just multiply both sides by 8. So the height will be 3.157 ... That's what this side is here. And I'll write that on in green, 3.157 ... And that's in centimetres if that was your final answer, but it's not, because we want to work out the area of the shaded region. So now we have this height here. We can work out this height now because we know the full length is 10 centimetres. This full length here is also then 10 centimetres because it's just from one point of the square up to the top. Okay, so this is 10 centimetres. So to work out the height of this shaded triangle, all we have to do is take that away from 10. And that will give me 6.84 centimetres. So I'll do it in red. 6.84 centimetres is this side here. Now, this is a square, so we can use the information of a square that all sides are the same. So this side, AB, must also be 10 centimetres. And then we can just work out the area of the shaded region. We have the base and we have the perpendicular height. This side here is perpendicular. So that's all we need to work out the area of the triangle. Even though it's not right angle, we know the base and we know the perpendicular height. So we can just work out, or use, sorry, our normal formula. So the final part of the solution is that we're going to do a half times the base times the perpendicular height. The base here is 10, even though the triangle's upside down, it's still the base. The base is 10, this is your perpendicular height, so we're going to do a half times the base times the perpendicular height, gives us 34.2 centimetres squared. So I'll zoom out so you can see the solution and question in full, and maybe just pause the video and have a look at that and make sure you understand every step. Really, there's nothing hard about that question apart from working out what to do and when to do it. It's just the sine rule, using some triangle information and then working out the area just using the basic formula. Okay, let's have a look at another example. Now, I've written the solution down on paper here, and I'm actually going to do it with you. So, let's read the question. It says the triangle ABC, in triangle ABC, AB is 14 centimetres, BC is 12 centimetres, and CA is 15 centimetres. Part A says find the size of angle C, giving your answer to 3SF. 3SF just means significant figures. And then part B says find the area of triangle ABC, giving your answer in centimetres squared to 3 significant figures again. If it didn't tell you to give it to 3 significant figures, you can give it to whatever you like. In an exam though, check on the front of the paper and it will tell you what to give your answers to. Okay, so pause and have a go. I would recommend using all the information here to draw yourself a diagram of the triangle, and then really just use either the area, the cosine rule, or the sine rule and see what you can do to work out the answer. So pause and have a go, press play, and then we'll work through the answer. We'll do part A first, and part A, actually, once you draw a triangle, is actually quite simple, and so is part B, to be honest. So, I'm just going to draw the side AB flat to me, like the ground, okay? I'll do it along here, and that's just because it was the first one given to me there. I'm going to make that 14 centimetres, and I'm going to have this point A and that point B. Then it said BC is 12 centimetres, so BC will do something like that. It doesn't have to be perfect, it's just a sketch for you. That's BC, and then CA or AC, doesn't really matter which way you say it. Usually it's actually given in alphabetical order, but CA it's been given here. We're going to connect those two to make the triangle, and that side is 15 centimetres. So we want to find the size of angle C. Angle C is this angle here. We want to work out the size of that black angle there. So how can we do this? Well, I have all three sides. That's the only information that we are given about this triangle. So actually, let's go back to this here. All I have is all three sides. So let's go down the given table and let's see which one is all three sides. Given here, all three sides. And we are trying to find an unknown angle. That is good. So we want to use the cosine rule. And it's the angle version of the cosine rule that we want to use. So I'll write down the generic formula here. It is cos or cosine of A is equal to B squared plus C squared minus A squared all over 2BC. And that is really just remembered from practice. If you practice this, you'll remember the formula. What it really is cosine of the angle you're trying to find, that is equal to the square of the other two sides added together, minus the side squared that is opposite the angle you're trying to find, because A and A matches up, then divided by 2 times the two sides that are not opposite the angle. Okay, so let's just substitute into that. We're trying to find cos A, so I'll make sure the letters match up. Sorry, cos C, not cos A. Cos C, because we're at the point C there. Cos C is going to be equal to the square of the two sides that is not opposite the angle. So that's 12 and 15. 12 squared plus 15 squared, minus the side that is opposite the angle squared, so minus 14 squared, divided by 2 times the first two sides, 12 and 15. Okay, those kind of match up there like that. Okay, and then really it is just, can you calculate that with your calculator? And hopefully you can do. You will get cos C to be this. Cos of angle C will be 0.4805, and that carries on in your calculator display. And then it's just a case of doing inverse cos. C will be equal to cos to the minus 1. That's not a power, that's just the notation of the inverse cos. And it's going to be of the thing on the right hand side there, the decimal, because you're just doing inverse cos of both sides. And then you will get C, when you put that into your calculator, as 61.3 degrees. And actually, I can give that to 278 like that as the decimal points. But then our answer was to 3 significant figures. And so that is going to round, when you give it to 3 significant figures, to 61.3 degrees. And I always like to write 3SF if I ever round my answers. So that is the size of angle C. Okay, part B was this. It says find the area of the triangle ABC, giving your answer in centimetres squared to 3 significant figures. I'm going to write this on here, that's 61.3 degrees. And now we want to find the area. So if we think about the formula for a minute, it's a half AB sine C. I'll write it here. The area is a half AB sine C. And if we go back to the table, we need to use that formula. We need to be given 2 sides and the angle between them. Then we can work out the area using this formula. Well, I have got 2 sides here, AC and BC. And when I say I've got 2 sides, I mean I know the length of them. I've got this one as well, but it's no use because if we ignore that AB for a minute, these are my 2 sides and I've just worked out the angle between them. So it's simple to work out the area. And I'll do part B here. The area, we're going to use that formula, and it's going to be a half times AB, it actually works out nicely. This is side B and that's side A because they're opposite the angles there. But even if it's not, you can interchange the letters. It's basically two sides with the angle between them. These are your two sides multiplied together, and then C is the angle between them. So a half times 15 times 12 times sine of 61.3. Make sure you're in degrees and you will get this. The area is 78.94 ... and then to three significant figures, that's 78.9 centimetres squared to three significant figures. And that is the area of the triangle. So actually, not very difficult. Can you just use the angle version of the cosine rule, and can you use the area formula? Hopefully you can. All right, final example for this lesson. We are trying to find the value of x. Now, it doesn't tell you what x is, so first of all, identify what is x, where is it on the diagram, and what are my units going to be. Kind of think ahead before you've done the solution. I can see that x is right there, so we're going to need to work out the angle. Okay, so pause and have a go if you want to. Think about the information that you've got, have a go, then press play and I'll work through the answer. Right, I'm going to note that x is an angle, so I've got that in my head for the question. X is an angle, and we'll even underline it, okay? So I'm thinking degrees for my answer. And it's always useful just to think ahead of the solution so that you are kind of aware and you don't make mistakes as you go along or give the wrong unit at the end, because that's just kind of easy marks lost in the exam. So the first thing I'm going to do is I am going to work out angle B. And the reason I'm going to do that is because I have here this full side. I can work out the length of it. And the reason I can work out the length of it is because I can just add the two sides together. I can add 2.4 and 8.6 to give me 11. So this full side, AB, is 11, and I'll put centimetres there. So what I have is, I have a side, and then the opposite angle is this angle here. So I'll highlight it, I won't do it in grey, I'll do it in yellow. This angle, and then this is its opposite side. Okay, I also have then in green, this side, and this is its opposite angle. That green angle there. So what I did is, first of all, work out the size of angle B. And we can see I can do that because I can use the sine rule. The reason I can use the sine rule is because we actually can already work out what the angle, the green angle is. Because we have a straight line here, and we know that this angle is 50. So this full angle, I will do, and I'll write it in proper maths actually, angle, and it will be ACB, is equal to 180 minus 50, which is 130 degrees. Because we've got a straight line, this is what angles on a straight line add up to. We've already got 50 degrees, so what's the rest of the angle there? It's going to be 130. So this angle here is 100, maybe I'll do that in a different colour, is 130 degrees. Okay, now I can use the sine rule now to work out what angle B is. So I'll write that here. Sine rule for angle, and it's angle ABC, I should really put. It's just the angle that is situated at point B. Okay, so working that out, I'll do a semicolon there. This is what I'm going to get. I'm going to get sine of 130 divided by its opposite angle, 11, will be equal to another ratio, sine of angle ABC, divided by the side opposite, 3.8. We've basically just used the sine rule, and if you're unsure of that, have a look at another video. This is sine of 130 here, divided by the side, that's where this comes from. That's in ratio to sine of this angle divided by its opposite side. That's where those arrows connect. Okay, we have that, and then all I want to do is work out angle ABC. So I will just get sine of ABC will be equal to, and I'm just going to multiply both sides by 3.8. I've also flipped the equation as well. 3.8 times sine of 130 divided by 11. If you put that into your calculator, you get this. Actually, I don't know that from your calculator, but I do know if you take the inverse sine, let's do that actually. The inverse sine of that, so sine to the minus 1 of 3.8 times sine of 130 divided by 11, that will be equal to 15.345 degrees, and I've given that to 3 decimal places. That is this angle here. Okay, 15, and I'll make that bit orange, 15.345. So we've done that so that we can work out angle A. Okay, we can work out angle A because we can look at this triangle and say we know what this one is, we've just worked it out, we know what this angle is, and so I can just take away from 180 the sum of these two to work out this angle here, because angle sum of a triangle is 180 degrees. So I'll do that here, hence angle A, and it's actually angle BAC, we'll write it properly. Angle BAC will be 180, because that's the angle sum of a triangle, minus the sum of the angles that are already there. 130 plus 15.345, and of course that's degrees. That gives me, when you put it in your calculator, 34.655 degrees. That is this angle there. Okay, so what can we do now? Well, if we think about it, what we have now in just this triangle here, I know it's getting a bit messy, but I just want to focus on that shaded triangle there. In fact, I might even draw the triangle out again. Let's do that. We have this triangle here. It's gone green for some reason. We have A, C, and D. This is angle X. This is 34.655 degrees. This is 2.4 centimeters, and that's 3.8 centimeters. Okay, let's take this and let's put it down here. All I've done is now just taken that grey triangle and drew it out again. Okay, I want to work out angle X. I have basically used all the information from this big triangle now, because if you are sort of got a beady eye on this question, you can see we're going to be able to work out X just from this information here. What I have is I have two sides, and I have the angle between them, and I want to work out another angle, okay? So what can I do? Well, I'm going to work out the length of DC. And the reason I'm going to do that is because I have two sides and I have the angle between them. And then if I do that, I will know what this side is here. And then I can use the sine rule because I have a side here that I'm about to work out and its opposite angle. And I want to work out this one here, so I have X, and I know its opposite side, so I can just use the sine rule. Okay, let's do that. So the length of, I'll do it in black, the length of DC, and sometimes it's actually written like that, okay? Just be careful of that. So DC is, and we're going to use the cosine rule here. I'll put that in brackets because we've got two sides and the angle between them. So DC squared, because that's what the cosine rule is, it's A squared, but we'll change it to DC squared, is equal to B squared plus C squared, the other two sides squared, so 2.4 squared plus 3.8 squared, minus 2 times AB, which is BC, 2.4 times 3.8 times cos of the angle between them, 34.655 degrees. When you put that in your calculator, you get DC squared is equal to 5 5.19594, and that carries on. We don't want DC squared, we want just the length of DC. So remember from the cosine rule, we just need to square root our answer to get DC, and that being our answer, 5.19 ... So when you square root that, you get 2.279 ... to 3 decimal places. Of course you get plus and minus there on the square root, but we're working out a side, it's a length, so it has to be positive. Okay, so I'll write that in red, I'll highlight it in red, and I'll write it in red here, 2.279 ... centimetres. So now what we have is, we have this side, and we have the known opposite angle here. And we have this side, its known length, and we want to work out this angle here. So we can just use the sine rule to work out angle x, which is what we wanted to do in the first place. We want to find the value of x. So, last part of the solution, sine rule for angle x. Let's do that. We're going to have sine of x divided by 2.4, that's the opposite side, is equal to sine of the other angle, which is 34.655, divided by 2.279 ... because that is the opposite side to that angle. Then all we need to do is just do sine of x, and we can do that by multiplying both sides by 2.4. So we'll get 2.4 times sine of 34.655 in degrees, of course, divided by 2.279, and that carries on. And then we could just take the inverse sine on both sides. So inverse sine of this, I'll probably put that bit that I've circled there or boxed off there in your calculator first, but you don't have to. It will just reduce errors if you do. We'll duplicate that there. We're taking the inverse sine of that to give me x is equal to 36.8 degrees to 3 significant figures, okay? You do get this as 36.7857 ... and it didn't actually tell us what to give our answer to, but 3 significant figures is always nice. That is your final answer. It's in degrees because x was an angle, and we noted that at the start of the question.